Hello students, today we are going to discuss about wireless LAN. It is one of the chapter of module 3. Okay, so basically wireless LAN comprises of some of the topics like architectural comparison, characteristics and IEEE standards, that is 802.11 architecture, addressing mechanism, physical layers, and also some of the concepts of Bluetooth, like how basically a Bluetooth architecture is and what are the different layers of Bluetooth. Okay, so to talk about wireless, basically wireless is one of the fastest growing technologies. The demand for connecting devices without the use of cables, okay, is increasing everywhere basically. And these wireless LANs can be found in almost like college campus, in office buildings, and in many areas, public areas. Okay, now let us start with the architectural comparison of wireless LAN. If I consider medium is one of the parameter, then in wired LAN we make use of wires to connect the hosts. In case of switch LAN, there will be a link layer switch using which the communication between the host becomes point to point and full duplex. Okay, in case of wireless LAN, as the name indicates, the medium is air and the signal generally is broadcasted, wherein which when the information is sent, all the receivers will receive the information. Only the intended person will keep the information, remaining will discard the information. Okay, and basically when hosts in a wireless LAN communicate with each other, no, they are sharing the same medium with having a multiple access for the medium. So this is a difference between the wired LAN, switch LAN and wireless LAN, keeping a parameter called medium. Next, let us consider about the next parameter, that is host. Basically, in case of wired LAN, the hosts are always connected to a network, and this network has a link layer address that is fixed. Like you have studied previously, that is the network interface card, which has a link layer address. That link layer address is constant or a fixed for a device or a host. Now, basically here a host can move from one point in the internet to another point, but here the link layer address remains the same. But in case of a wireless LAN, the host is not physically connected to any network and it can move freely and can use any services provided by the network. So this is the basic difference between the wired and wireless LAN in terms of a host. Next, let us talk about isolated LAN. Basically, in case of an wired isolated LAN, okay, in case of wired isolated LAN, there will be a link layer switch, and all the devices are connected to this link layer switch through cables. Okay, and here in case of isolated LAN, wired isolated LAN, the switch is having a it acts as like a hub. Okay, so all the devices who wants to communicate with one or the other devices, they have to communicate through the switch. But in case of wireless LAN, okay, it is like it, you can call it as an ad hoc network. Okay, here the hosts are free to communicate in a given network. So this is basically, you can call it as an ad hoc network, and the concept of link layer switch does not exist in case of wireless LAN. Okay, now let us talk about how the connection to other networks happens in case of wired LAN and wireless LAN. Basically, in case of wired LAN, you will be having a switch. As I told you, switch is connected to multiple devices, and to communicate with any other wired internet or network, you need to make use of a router. So router is the one who connects the different networks. Okay, so between two wired networks. But in case of wireless LAN, there will be an access point which acts as like a base station, and all other mobile devices which are freely moving within a given network, and this access point is connected to a router physically, and basically this can be in turn connected to any wired infrastructure network or wireless infrastructure network, or like to another wireless LAN itself. Okay, so that can be considered in case of wireless LAN. So wired LAN and wireless LAN, basically they are connected to a router, and this is connected to a wired network, and here the infrastructure could be anything like wired, wireless, or even a wireless LAN also. Okay, so this is all about the comparison between the wired and wireless LAN in terms of connectivity to other networks. Now let us talk about one more parameter. Whenever we are moving the networks, that is from wired to wireless, whenever you want to switch over from wired to wireless LAN, basically we need to deal only within the two layers of TCP/IP protocol. So that is the lower two layers, which is a physical layer and data link layer. Here in case of wired LAN, if you consider in a building that is connected to a router or a modem to the particular internet, okay, so all we need to do is just switch over the wired environment to a wireless environment by just changing the network interface card, because that contains a link layer switch with an access point, so which gives a wireless environment. But in case of wired environment, you will be physically connecting it to a switch. Okay, so here in this case link layer addresses will change because of changing the NICs, but the network layer address, that is what we call it as IPs, will remain the same. Only the link layer address will change because of changing the NICs from wired to wireless. Next, let us talk about the characteristics of wireless environment. There are several characteristics of wireless LAN. Basically, one of the characteristic you can consider as an attenuation. Normally, in case of wireless environment, the strength of the signals would decrease rapidly. Since the signal, once it is passing through an air medium, it disperses in all the directions. Only a small portion will reach the receiver. So, basically, this situation becomes again worse with the mobile senders that operate on batteries and normally have very small power supplies. So, basically, what happens? The signal becomes degrades, or it strength decreases rapidly. So that is one of the characteristics of wireless LAN. And to talk about interference, that is also one of the issue of wireless LAN. Here the receiver may receive the signals not only from the intended sender but also from other senders. So say for example, if they are using the same frequency band, this may happen because of the interference which is happening between the different signals. Next, let us talk about one more characteristic, that is multipath propagation. Here, normally what happens, a receiver will receive the same signal, that is one signal from the same sender, but because of the electromagnetic waves which are reflected back from the obstacles such as walls, grounds, or objects, even any obstacles, if you just consider, okay, the result, what happens, instead the same signal would take a different paths. Okay, so the receiver would receive the same signal multiple times, okay, because of the propagation path which is varying, and the receiver would sometimes when one receiver is receiving the same signal multiple times, and receiver would not be able to recognize which is the original signal or which is the right one. Okay, so because they are going to travel in different paths, that is called as multipath propagation. Now let us talk about error. That is also one of the characteristics. Whenever basically SNR is high, that is signal to noise ratio is high, that is here it means that signal is stronger than the noise. Okay, we are able to convert the signal to actual data, but whenever it is low, right, that is when the signal strength is lesser when compared to that of the noise, here the signal is corrupted by the noise and data cannot be recovered at the receiver end, which may lead to an error situation. In that situation, the receiver has to discard the error packet whatever is been received at the receiver. Now let us talk about the access control in wireless environment. A wireless host can get access to the shared medium, but in case of CSMA CD algorithm method, each host contends to access the medium and sends its frame, and if it finds the medium idle, okay, if the collision occurs, it is detected and the frame is sent again. But here in case of collision detection in CSMA CD, basically it serves two purposes. That is, if collision is detected, it means that the frame has not been received and needs to be resent again. But if the collision is not detected, it is a kind of acknowledgement that the frame was received. So you will not get any acknowledgement physically like how you get it in case of wired environment. So here if there is no collision, so it is an acknowledgement wherein which the frame has been received. Okay, now this kind of CSMA CD algorithm, basically it does not work for wireless LAN, but there are three reasons why it is not going to use for wireless environment. One is like to detect the collision, basically one may has to, or a host may has to send and receive the information at the same time. Say for example, sending a frame and receiving the frame which there could be a possibility of collision, right? So but wireless hosts do not have enough power to do so. so they can only send or receive one at a time. So to detect the collision, that becomes CSMACD technique may not be work for wireless LAN. And second problem is that is a hidden station problem, which we have already discussed. That is, a station may not be aware of another station sending the information due to some obstacles or range problems. Consider there are A, B, C, and there are three stations. A does not know whether C is sending to B, because A also wants to send to B and C also wants to send to B, but A does not know whether C is C also wants to send information to B. That is, C is hidden from station A. Okay, so that also one of the reason where in case of wireless LAN, the CSMACD technique may not be considered, or that may not work for wireless environment. Next is the now here let us talk about the hidden station problem. As I told you, there are three devices. Okay, now C is in the range of one network, and B is in the range of B. Okay, and A lies in between B and C. Now here what happens, A is in the vicinity of C. Now C can access A, even B can also access A, because A is in the border, or you can consider that is an A is connectable to both B and C. Now B does not know whether A is in contact with C or not. Okay, or C does not know even whether B also wants to send the information. Say something like BAC, where C is hidden from B. Okay, so they are hidden from each other. So in that situation, there is a possibility that both sends the information at the same time, where the collision probably may occur, and A may have to discard both the packets which are received by B and C. And using a CSMACD, the third problem is basically the distance between the stations can be large. Okay, so due to which the signal fading may happen, and if any collision also occurs, no, that time it may not be heard at the other end. Okay, so because the distance is very larger. So to overcome all these three problems, that is why we are not going to use CSMACD technique for wireless LAN. Now to overcome all these problems, we go for CSMACA technique, that is carrier sense multiple access collision avoidance. Okay, which is basically invented for wireless LANs. IEEE 802.11 project, basically this is meant for it defines specifications for network. Okay, so here IEEE basically they define the specifications for even wireless LAN also, that is called IEEE 802.11. Now here it covers the physical and data link layers, and we also call it as a wireless Ethernet. And in some countries like US, the public, they use a term called Wi-Fi, that is wireless fidelity, that is a synonym for wireless LAN. Okay, now let us talk about the architecture of this, how basically it works. Okay, the architecture comprises of basically two kinds of services. One is BSS, other one is ESS. BSS stands for basic service set and ESS stands for extended service set. Okay, so IEEE 802.11, they define BSS, it's a basic building block. Okay, building block of wireless LAN. Fine, so we will discuss how this BSS will be existing and how does that is been supported by the ESS. Okay, so this is the picture or a diagram of BSS. Okay, so a BSS is a set which is made up of stationary mobile wireless devices, or like mobile wireless stations, and may or may not be having an access point. Okay, if you have an access point internally in a network, we can call it as an infrastructure BSS, and if you don't have an access point, then it is called as an ad hoc BSS. Okay, so there are different types of BSS. We could see that ad hoc BSS and infrastructure BSS, and this access point serves as a base station within the particular network and gives a connectivity between one BSS to another BSS, and we will see what does access point does some of the work. Okay, but here if you don't have an access point, you can call it as an ad hoc BSS. Okay, let us discuss about the extended service set. Here extended service set is made up of two or more BSS with access points. Okay, so basically in this case the BSS are connected through a distribution system, which is a wired or again it can be a wireless network. The distribution system connects these APs which are present in the BSS. Okay, and this IEEE 802.11, they does not restrict the distribution system. It can be again any IEEE LAN. Okay, the ESS uses two types of stations, mobile and stationary. Okay, the mobile stations are normal stations inside a BSS, and stationary stations are access points. Okay, access points that are part of this wired LAN. Okay, and they are connected through to the distribution system through a wired means. Okay, when BSS are connected, the stations within the stations within the reach of one another can communicate without the use of an access point. But here communication between the station, that is in one BSS to another BSS, occurs via the access point. Okay, and here the mobile station can be, it can belong to more than one BSS at the same time. Fine. And there are different station types. Okay, now we are going to consider different station types. We will discuss that what are those different station types here. Okay, there are three different station types according to IEEE 802.11. They defines as no transition and BSS transition, ESS transition. So basically, in case of no transition, the mobility is either not moving, or if it is moving also, it should be within the BSS, within one single BSS. And if it is an BSS transition, then mobility is from one BSS to another BSS, but the movement is confined within one ESS. Okay, so in case of ESS transition, it can move from one ESS to another ESS. Okay, and normally this IEEE standard does not guarantee the communication is continuous during the movement. Fine. So hope you all understood the topics whatever so far we have discussed here. Okay, and we will continue some more topics in the coming session. Well, thank you all.